And to finish the chain rule topic, let's work the general version of it. We already covered some examples of partial derivatives, many examples of how to calculate that, and how to apply the chain rule when you have a more than one variable dependence on the response variable. Now, let's go a little bit further, and let's suppose that we have a function u, and that u is differentiable function of the n variables x sub 1, x sub 2, x sub 3, all the way up to x sub n. But each one of these x's sub j are differentiable functions of the m variables t1, t sub 2, t sub 3, all the way up to t sub m. So u is dependent of x and x are dependent on t. But because we have a chain rule here, because x behavior depends on the change of t, then the change of u depends on the change of x and also depends on the change of t. So u at the end is a function of t from t sub 1 all the way up to t sub m. And the way to express that in terms of partial derivatives is that if we want to know the differentiation for that function u with respect to t sub I, or whatever amount of t's we have, is equal to the partial derivative for the function with respect to x times the partial derivative of x with respect to t sub I plus the partial derivative with respect to the second x times the partial derivative of the second x with respect to t sub I, and so far so on, all the way up to the partial derivative of the function with respect to x sub n times the partial derivative of x sub n times t sub I. Okay, maybe it sounds a little bit messy at the beginning, but once we develop the next example, I'm sure that it will be more than clear for you. Okay, in this example, we are not going to work any algebraic operations. What we are going to do is to structure or to write the chain rule for this type of expressions. Okay, let's say, for example, that we have a function w, and w is equal to a relationship f of x, y, z, and t. We have a four variable function, and this x function depends on u and b, and the y function depends also in u and b, the z function depends on u and b, and the t function depends on u and b. So we have a multiple chain rule and a multiple dependence of variables, and we have more than two variables here. So this is a big, huge uh, chain of relations. Okay, how can we write the chain rule? Because we need to write it first and then solve it. Maybe the easier part for us is to solve it because we have the differentiation tables. And the hard part is to get all these arranged so you can calculate it without mistakes. Okay, one method that we can find in the textbooks that we can write some kind of tree diagram. So this is the y, the w, which is the dependent variable, and we have all these four variables, which are, let's say, x, y, z, and t. Okay, so this is our variables all depend on w, and this w has u and b, and this y has u and b, and this z has u and b, and t is dependent on u and b. Okay, now with these three, it's more easy to write the relationship. In this, we can um, break this into change. Why? Because we have this number one and number two, uh, which is the m part. So this is all the way down in two parts. So we need to write it something like this. This is a partial variable w of u, because we are going to set from here to here. Okay, so we are going to find the rate of change from here to here, passing through x, passing through y, passing through z, and passing through t. Okay, so this is going to be equal to the partial derivative of w with respect to x times the partial derivative of x with respect to u plus the partial derivative of w with respect to y times the partial derivative of y with respect to u plus partial derivative of w with respect to z times the partial derivative of z with respect to u and the partial derivative of w with respect to t times the partial derivative of t with respect to u. Okay, and now you can do all the differentiation for each one of these terms, make the products, and make the sums, and you will have the differentiation from w with respect to u. And in the other way, we have this w all the way down to b. So that's going to be the partial derivative of w with respect to b. And it's going to be equal to the partial derivative of w with respect to x times the partial derivative of x with respect to b plus the partial derivative of w with respect to y times the derivative of partial derivative of y with respect to b plus the partial derivative of w with respect to z times the partial derivative of z with respect to b, the partial derivative of w with respect to t times the partial derivative of t with respect to b. Okay, so this is we need to break down this in two parts because at the end we have two variables here, and there is no another branch all the way down on this relation. So we need to find the product rule from this, from here to here, and from here to u, and from here to x, and from w to b. So this is the chain rule in the general expression. And once you have some practice with this, no matter what kind of expression or function you have, If you remember this little graphic here and this logical sequence, it's going to be easy for you to give a structure to the chain rule. I think the hardest part is this one, and later you can apply your differentiation rule to end up with this expression and have a result. But if you have this first and think a little bit about what is the relation between the first level of variables and the second level of variables, and even if you have a third level of variables, what the relation is, and you can structure it like this and come out with your results. Okay, so that's the way that the chain rule in general version is done. As always, please let me know if you have any questions or comments. I will be aware of them, and I hope to see you soon.